Good morning, students. So this is a topic which I couldn't cover in class, so I'm telling it here. So this is deflection of pin jointed plane frames. So we've seen the procedure of method of joints to find the forces, member forces in a truss or a pin joint frame. So here we'll see how to find the deflection. So in the problem, they'll ask you to find the displacement at a particular joint. So what we have to do, first we have to remove all the forces. We have to remove all the real forces. So 50 kN, 100 kN, some force will be acting on the truss. So that force we have to remove. Then we have to apply unit load. Where we have to apply the unit load? Where the displacement or deflection is required. Okay, so we have to remove all the real loads, apply a unit load at the desired location where displacement is required to be found out. After that, we are using method of joints. We have to find the virtual forces K, small k. Then as usual, real forces. So this we already seen in chapter 1. So using method of joints, we find the real forces. Then using the virtual work equation. So what is the principle of virtual work? You see here, UE is equal to UI. So UE means external work done equal to internal energy stored in the structure. So that you can remember. So principle of virtual work is external work done is equal to internal energy. So using that, this equation is derived. So displacement delta equal to summation KFL by AE. So A is area of cross section, E the Young's modulus which will be given the problem, L is the length of the member, so which has to be found. So see here, determine the vertical displacement of joint C of a truss shown in figure. So cross sectional area A equal to 400 mm square and E equal to 2 into 10 power 5 Newton per mm square. So here you see you have two vertical loads, real loads, 50 and 50. So now again we know that delta equal to summation KFL by A. So K is virtual force, F is the real force. So first for virtual force K, you have to remove all the real force. See, all the real force has been removed. So both 50-50 removed. Then you have to apply unit load. Where you have to apply the unit load? Vertical displacement of joint C. So at C you have to apply a vertical unit load 1 kN. So using this, first you have to find the reactions. Then as usual method of joints, take joint one joint by the other and find all the forces. Okay. So similarly you have to move until you find all the forces. Then you have to find the length. Then step 2 is real force. So here method of joints, you have the real forces. Again find the reactions. Then find the real forces. So virtual force will have, if it is AB, we'll have it as KAB virtual force. And real force will have F, capital FAB. Okay. So you have to find all the real forces. Now if the length of the member is not known, that you have to find out. So if you see here, the length of the members are given. So AB 3, BC 3 and CD 3. So the inclined members has to be found out. Vertical members FB and EC equal to 3 meters. So only the inclined members AF and ED has to be found. That is simple. So what will be AF? AF equal to square root of FB square plus AB square. So only that has to be found out, which has been found out here. See here. So that's all. Then we can have a table. So member K is a virtual force, F is a real force, and L is a length. So you have to multiply KFL and you have to find the summation KFL. That divided by AE will give you the displacement. Okay, so do this and tell me the answer. So that's why I have not given you the answer. Hope you understand. Thank you.